Alright, can you guys do a problem like this? Simplify 3x to the 5th times 9x to the 3rd. And also, let's do a wild one. Let's do x to the 13th, y to the 4th, over x to the 9th, y squared. So go ahead and simplify both those. Give it a shot. Did you guys get 3 times 9 is 27? What do you do with your exponents when you're multiplying? Add them. So if this is the only thing on the test, would you guys be pretty content?
Yeah.
It's one of the things on the test. What do you do with your exponents on this beast? Subtract them. Subtract them. Alright, here, try this beast out. Solve this. Now, I will say this. Interestingly enough, this is from an earlier section where we use reciprocals to solve it, like reciprocal powers. You have a new tool to solve this now. So there's actually 2 ways you can solve this. How do I get rid of a 1/4 power? Use the reciprocal. I take it to the -4/1 power. Whatever I do to the left side, I can do to the right side. Oh, Jiminy Crickets, that's going to be a small number. Sorry for my language. So left side becomes x, and then I plug that in my calculator. So I do 2,5. It's going to be pretty messy, actually. Wow. Now here's my question. Is that going to be a really big number or a really small number, do you think? Huge. 8.42. So I did 1/4 to the -4. Oh wait, no, that's wrong. No, the answer wasn't negative.
No, but like the -4/1.
That can be negative. You can take something to a negative power.
I don't know, I thought it was supposed to be.
No, because remember, if you take it to a negative power, it means you flip it. That's the same thing as 4 to the 4th.
Let him know, Jonah.
A negative exponent, you flip the thing, or you can just plug it in. Alright, my internet people, solve this beast. So I'll give you a hint if you're struggling. We'll pause if you know where to start and finish, but if you don't, the hint I'll give you is this is the same thing as x to the 4/3 equals 12, right? Because that cube root is just a fraction. So that's x to the 4th to the 1/3. So it's x to the 4/3 equals 12. It's my first. What do I do to get rid of that 4/3? Take it to the reciprocal. So I'm going to take it to the 3/4. Because remember, they have to multiply. When you take a power to a power, you multiply. So that becomes x to the 1. And then, man, that camera's tripping out. So 12 to the 0.75 is, what do you guys think it is? Take a guess. 6.45 is a great guess. 6.45. Alright. So how do I get rid of a power? Take it to the reciprocal. If it's positive, it stays positive because they need to become a positive 1. Okay? If it's negative, you take it to the negative. It's just straight reciprocal, not opposite reciprocal. Alright? Alright. Bless you. Alright. What if I gave you this? We're almost a third of the way through the test already. What if I gave you f of x equals 125 times 1.05 to the x? And I told you to evaluate it, or find find f of 0.5, and find f of 1.38. Could you guys give it a try? This is a very calculator heavy section. Alright, sorry I zoomed way ahead for the people on Video World. You're just plugging this in your calculator, right? Question is, you invest $4,000 in an account that gets 3.35% continuously. How much will you have in 15 years? That's my formula if it's continuous. Alright, so we got A equals PERT. What's my amount? That's what I'm looking for. My principal's 4,000. E, my rate. Don't put 0.335. That's the number one mistake I've seen so far. 0.035 T. But what do I plug in for T? 15. Did I? Uh-oh. Alright, yeah, that's definitely visible. Plug in your 15. Where did I plug this mess into? Calculator. Number one mistake made with this I've seen so far. I don't know if you're going to be able to see this. Number one mistake I've seen made, which you guys won't do it, is make sure... Yeah, there's no way you're going to be able to see that screen. Well, make sure you're keeping that whole top part in those parentheses, okay? Because some people are taking it to the power. Oopsie. And then they're timesing the whole thing by 15. But you should get about $6,611.
Either way, it's like that.
Ta-da! Alright, so our parent function is 12 to the x. Describe the transformation that occurs to our parent function on each of these. Alright, so we have 12 to the x plus 4, negative 12x, 12 to the negative x, 12x plus 4. Give that a shot. What's this plus 4 going to do? Vertical or horizontal? Horizontal. Because it's what? Left 4. Remember, horizontal is left right, vertical's up down. Because this one's what? Vertical. I have a vertical of 4. That's pretty good.
You gotta know that horizontal and vertical.
Yes, I would. What's this negative in front gonna do? What does that flip it over? That's the biggest thing to keep in the back of your head. It reflects or flips over. Which one? Yeah, the x-axis. Because think about this. If you have a graph and you have this point up here, if you put a negative in front of it, you get a negative y. So it reflects over the x-axis if the negative's in front. If the negative's by the x, it's a reflex over the y-axis. Alright, try to solve each of these using log properties. Don't, nothing tricky here, but we're using the log property, right? Log base b of y equals x means b to the x equals y. That log property. That's what you're doing. Except for b. B's a, never mind, I'll let you try it. Let me try it. No, that's okay. Add snowy adverb. Alright, here we go. Let's go over this beast. We're using our definition. B to the third equals 125. Now, if you don't know your perfect cubes, these will always be a pretty good number. Like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed, 5 to the third is 125. So the answer is 5. So on the, hold on, let me pause. Alright, letter B. Even less work required. I'll show you the y. The y is, it says e to the y equals e to the 231. So if they have the same base, y is 231. Now some of you might be saying, but Mr. Williger, I already know that property that those cancel, and it's just 231. And you would be correct.
We do that really hard one.
Alright, let's try this beast. Simplify this to one logarithmic. Dealio. So there it is. Simplify that using our log rules. Oh, there's a camera. Alright, give it a shot. Simplify that beast. Let's go over this beast. So then, if you have a number in front of your log, it moves back as a power, right? So like, if I could rewrite this, I'd do 2x to the 4th, that whole thing to the 3rd. You're not wrong. Right?
Yeah.
Now what do I do when I'm adding these? What do you do with, or do you want to simplify these first? What do you guys want to do?
What's the easier
Whatever the
order?
text is gonna do.
Well, I'm same steps no matter what.
Oh, okay.
If you want to distribute this 3 through and this 4 through before you do it, that's fine. So that'd be 2 to the 3rd. What do you do with your powers if it's a power to a power?
Is that a power or is it just a 4?
That's x to the 4. My writing's just bad. That'd be x to the 12th. You gotta multiply those beasts. And that'd be 2 to the 4th, x to the 4th, y to the 4th. Because they all gotta get hit by it. I didn't have to do any multiplication there because I didn't have to. Hooray. Yeah. Oof. Alright. Now let's deal with that addition sign. If you want to, 2 to the 3rd is, what's that, 8? And 2 to the 4th is 16, if you want to get rid of those. Alright, now we just start multiplying stuff together, right? Because addition, right, means we do what with our numbers? We multiply. That's it. That's a rule. So 8 times 16 is 48, 128. No, it's not. Oh, it was. You gotta believe in yourself. So 8 times 16 is 128. X to the 12 times x to the 4th. What do I do with my exponents? I add them. And that y has no friends, like me. So it just stays. Alright? Just take it step by step on these. It's a lot of exponent rules, actually. So, try this beast out. Same thing, simplified to one logarithmic expression. Alright, what do I do first, usually? What do I do first? I'm gonna put that 3 over here. Right?
Oh, it's just like
To the 3rd. This is going to remain. They say red's an aggressive color. I'm going to make that 3 hit both those. That's just the way I roll. Again, you could do this many different orders. 9 to the 3rd is 729. Yep. I have to believe in myself. And what do I do with these powers? Do I add or multiply them? Multiply them. A power to a power gets multiplied. 9 times 9 times 9. Alright, so I dealt with that power first. Now I'm going to deal with that subtraction dealio. So when we subtract, up here when we added, we multiplied. So when I subtract, I divide. Again, this is pretty much a powers rule review. Because when I'm dividing, what do I do with my exponents? If I really want to get this simplified down to the final form. Oh, I don't need that. Ah. There. Yeah, because once I subtract those, I don't need to worry about it as much, right? Hey, look, it's subtraction here, then division, and then subtraction again. It's almost like this video is going to be very disjoint. Just a reminder, change the base formulas. If I want to get rid of my base, I can make it any base I want by doing log of my top number over log of my little number. Okay? So using that newfound information, can you all find, rounding to the nearest hundredths place, log base 4 of 2.5. Use this formula. Because there's not a log base 4 button on your calculator. Alright. Oh my gosh. So I would do natural log of 2.5 over natural log of 4. And just type that in my calculator, right? And that is 0.66. Here, you guys try one more. Try one more for me, because this is easy. Not easy points, but it's not a lot of work for points. Do you know what I mean? Let's do 0.2 to, ooh, I shouldn't have picked that number, that's fine. To the 41. Give that one a shot. Alright. Did y'all do natural log of 41? Divided by natural log of 0.2? And that's I got negative 2.31. All right.